mathematicians, and welcome to math lesson number 23, where we are going to be delving into the world of volume. Okay, so volume is how much space something takes up, right? So we've figured out the distance around the perimeter, we figured out the distance on the flat part, the area. Well, now we're going to move into the world of volume. So if we were measuring the volume of a liquid, then we could use a handy little cup measure like this to figure out how much liquid we've got. If we have something that's a little bit more blocky, well, we're going to have to figure out another way. Okay, so we can measure the volume in cubes. How many cubes does it take up? So this guy apparently is too big for our camera right here. Anyway, this is our happy thousands cube. Okay, and we can make our thousands cube by stacking up these 100 squares. Okay, so imagine I've got 10 100 squares all stacked up to make that 1,000 square. So we could actually take it apart so it fits on here, and we'll just look at the top. Okay, now if I was asked for the area of the top of this guy, then you would know area is equal to the length times the width, right? So it'd be 10 times 10. Or you could do that if you didn't want to multiply, you could add 10 plus 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 10. Anyway, that would be a waste of your time, but the math book is going to ask you to do that twice. You can handle it twice, and it's not that many times. Okay, so anyway, so in this case, our area would be 10 times 10, which is, leave room for the equal sign, which is 100 squares. Okay, now in our giant cube that doesn't really fit here, we don't just have one of these little guys, we've got 10 of these little guys. So we've got this chunk, and 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 this is hard to hold everything all together, and this chunk, and this chunk, and this chunk, and this chunk, and that last chunk there. Okay, so that would be like saying we have 100 squares plus 100 squares plus 100 squares plus another 100 squares plus 100 squares plus 100 squares plus another 100 squares plus another 100 squares. 1, 2, 3, 4, 5, 6, 7, 8 plus another 100 squares plus another 100 squares. Okay, and we know all together we add all of that up and we get one of these guys. We know that's 1,000 squares. Or 1,000 little cubes in this case. Oh my goodness. Does that seem like that would be really fun to add all of that up all the time? I don't think so. So it's way faster to use multiplication. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of those. So that'd be like saying 100 times 10 is equal to 1,000. Oh, that was so much faster. Okay, now we know this 100 came from the two sides of this square. So it was really 10 times 10. So we're saying that this 1,000 cubes here really came from 10 times 10 times 10. Okay, which is the length times the width times the height of this cube. So volume, the sneaky way of figuring out volume, it's the length times the width times the height. And no, it doesn't really matter which side of your cube you call the length, or which side you call the width, or which side you call the height, as long as it's 3 different sides of your cube. So let's try a couple of examples. Here we go, cube number 1. All right, so we know that volume, and now I'm going to be a lazy mathematician, it's going to be the length times the width times the height. Okay, so we have to figure out which side. Let's make this side, let's make this the width. Okay, so this is going to be 2 squares. Let's call it 2 centimeters. And let's make this side the length, and it is 3 centimeters. Okay, so that's like looking at the top, right? Oops. So that's like the top of this thing, right? We just looked at the top to get the length and the width. And then next, we have to go down the side, which gives us the height, which is 2 centimeters. Okay, so for our volume, we've got 3 centimeters times 2 centimeters times 2 centimeters. Okay, 3 times 2 is 6. 6 times 2 is 12. So I've got 12 centimeters times centimeters times centimeters. I think you can probably tell what's coming. That's right, it's a lazy mathematician moment. Who on earth would want to write centimeters times centimeters times centimeters every time they have to write a volume? What a waste of time. So instead, we're just gonna write centimeters once, and then we count how many there are. 1, 2, there's 3 of them. So we're gonna put a little 3 up above it here. And because we have made a cube, we call it cubed. Okay, so it would take 12 cubes of 1 centimeter size to make this shape. Obviously, mine is not exactly to scale. It's a model. Okay, let's try one more. Okay, check out this giant cube. It was so giant it actually doesn't fit entirely on the whiteboard, but you can use your imagination. Okay, so again, we need the width. So I kind of like to either go around the top and the side or go around the bottom and the side. That makes my life easier because it's really hard to write things kind of in the middle of the cube here. That just gets really awkward. So I'm going to call this the W, the width. This side here, 1, 2, 3 centimeters. Then we'll call this side the length. 1, 2, 3, 4 centimeters. So then we have to look for the height. So that would be this part. How tall is that cube? And it's also going to be 4 centimeters. Oh, sorry, you can't see that. There it is, 4 centimeters. Okay, so my volume is going to be the width times the length times the height. So I'm going to do 3 times 4 times 4. All right, here comes some math fun. All right, so we've got 3 times 4. Hope you're with me there. We're 12. Okay, now 12 times 4. You might need to look at your multiplication charts for this one. We've got 12, 24, 36, 48. 48, and there's 3 sets of centimeters, so it's centimeters with a little 3, which we say 48 centimeters cubed. All right, so that should be everything you need to know to solve the volumes of this shape. One last thing that I didn't tell you is that this shape is called a rectangular prism. So you might have seen a triangle prism that you might put in your window to make rainbows. This one's just a rectangle one. So not quite as exciting, but nice, easy math. Okay, length times width times height. So if you have a green math book, you are going to do page 288, 289, and 290. And if you have a blue math book, you're going to do page 295 and 296. Okay, good luck, happy mathing!